Okay, so in grade 12, your first three topics are normally sequences and series. So sequences and series. So that's about 3 to 4 weeks, depending on how your school does it. And then normally topic number 2 would be functions, and particularly inverse functions and log functions. And the log function is just the inverse of an exponential function. So that's where it ties together. And then topic number 3, it's normally, I think it's a bit of trigonometry. Actually, let me go and have I got my grade 12 booklet here. Grade 12, I don't. So I think it's pretty much normally trigonometry. And we also have some analytical geometry that comes in too. So some schools play around with that. Okay. So normally your first test in grade 12 is going to be on paper 1, stuff like this. Sunday, does that answer your question, or do you have any more details you'd like to know? Okay, fantastic. Okay, well, let's have a look at this idea of what an inverse function is. So let me actually just, instead of these funky functions here, well, let me take this one here, and let's think of that function as y equals 3x plus 12. In fact, let's move everything else off the page so it's not distracting. So okay, so we have this function y equals 3x plus 12. What this function does is it multiplies whatever the input is by 3 and adds 12. Earlier on in your maths education, you may have seen it done something like, how would we represent this? We need to multiply something by 3, and then we need to add 12. And like this would be the input, and then on the other side would be the output. Give me a thumbs up if that drawing makes sense to you. And if I said to you, I'm going to put 5 is going to go into this flow diagram, could you tell me what would come out the other side? I see someone else joined us, so welcome to Tamir. Tamir, we are just doing a preview of a grade 12 section in functions, and it's called inverse functions. And we're just remembering how flow diagrams worked back in grade 9 and grade 10, where we describe rules and relationships like that. So if we go 5 times 3 is 15, plus 12, we get 27. Now, if we think about going through it like the function way, we'd go 3 times 5 3 times 5, yes, plus 12, which would give you 27. So we get the same output of 27 if we go through the formula or we go through the flow diagram. Okay, now, what is an inverse function? This is the question. So let's say, instead of y, we're going to say f of x equals 3x plus 12. And then I say to you, before I even move to that, if I say to you, that's a 9, I want you to work out for me, what is the f of 9? What is the f of 9? So we would go 9 is the input, times by 3 is 27, plus 12, and we would get 39. Or if we visualized it this way, we would get 39. Okay, so in this thing over here is actually called the function f. And I put the x into the machine does its thing, and out pops it sort of the value on the other side. Now, if I wanted to go backwards, if I wanted to go from 39 and go back to, if I wanted 39 as the input and I wanted to go back to 9, what do you think I would need to do? You can just use it in words. Tell me in words, or if you start at 39, the input is 39 and you need to get back to 9, what do you think I need to do? Okay, so in words, to go backwards, let me see if I can spell this, backwards, I would need to take away 12, and then I would need to divide by 3, because I'm using the opposite operations to here. I'm using the inverse operations. Remember inverse? It undoes what the original does. So the inverse of plus 12 is minus 12. The inverse of times 3 is divided by 3. Give me a thumbs up if you're with me on that. Okay, so if I had to build a new machine, and this machine's job was just to go backwards, we are agreed that I should take away 12 and then divide by 3. So give me a thumbs up if you agree. This is the forward machine. And let's say this is the backward machine. Okay, so I'm going to put in to this machine 39, and what will come out the other side? What will come out the other side? So 39 take away 12 is 27, divided by 3 is 9. Oh my goodness, the backward machine works perfectly well because it sent 39 back to 9. Okay, I'll tell you what. What if I give this 27? What is the backwards machine, or what I'll call the inverse machine, going to give you if you give it 27? Well, 27 take away 12 is going to be 15, and 15 divided by 3 is 5. Oh, but that also makes sense because look, 5 gave us 27. So what I've been trying to do here is show you something called the inverse function. And what the inverse function is, it takes whatever you did originally with the function and just sends it back to where it started, or it undoes it. So now what I'm going to do is I'm going to show you the special notation we use for the inverse. So if we've got an original function of f, we call the inverse function the f of minus 1. Now, this does not mean to the power of minus 1. It just means this is the inverse function, or the inverse. So I shouldn't say function because there's also something about a function definition we need to cover. But the inverse of this is that. Now, you said to me that all I need to do is take away 12, all right? And then I needed to take whatever that was and divide it by 3. And that should be the inverse function. Give me a thumbs up if you're okay with that. Let's just check that it does work for interest's sake. So if I go, what is the f of minus 1 of 27? Well, 27 minus 12 is 15, divided by 3 is 5. Okay, so it turns out my funky new notation does do the job. However, I want to point something else out. I could also write this as x over 3, or 1/3 x minus 4. Now, who can tell me what has happened? I'm saying that these are the same thing. Who can tell me how that was able to happen? Who can tell me how that was able to happen? Well, there's a 1 in front here. So when you divide 1 by 3, you get 1/3 x. And when you go minus 12 and you divide it by 3, you get minus 4. So you can also write the inverse like this. It looks neater, which is quite helpful. It's just that you lose a little bit of the understanding of why you're taking away 12 and dividing by 3. Give me a thumbs up if you understand how these two are the same thing. They just look a bit different. Okay. Let's do another example, except this time you're going to do it a bit more by yourself. Okay, so I'm going to make up another function, and this function shall be called g of x is equal to 2x minus 3. Okay, g of x is equal to 2x minus 3. Can you find me the inverse function of this one over here? And the one hint I will give you is that if you want to visualize the function g, I think timesing by 2 and subtracting 3 is a good way to start. So I want you to tell me, what is the inverse function of 2x minus 3? Okay, so if we look at it here, didn't you tell me last time if that's, don't we have to just undo, send it backwards? So if I'm going from here to here, like if I go, this is 5. 5 times 2 is 10. 10 minus 3 is 7. If I'm going backwards, it looks to me like, what do I have to do? Or what's the opposite of minus 3? It's plus 3. So I'm going to put x here, and I'm going to go plus 3. Is that the inverse, or do I need to do something more? Oh, Tamir said add 3 and divide by 2. I completely agree with you. Okay, so this is the inverse function. Can you write this for me in the standard form of a straight line? Can you write this as the standard form of a straight line now? So this is completely correct. It's the inverse, but can we write it in a format that we're more used to with straight lines? Sunday, let's go to you. I see your hand is up. Oh, did I miss it? Ooh.
No, sir.
Oh, you can hear me.
Sir, the equation is gonna be 1/2
Yeah,
x plus 3/2.
perfect. Thank you so much. You are completely right. So now, if this truly is the inverse function, it should undo what the original did. So let's check with the inverse function. If I say, what is the inverse of the number 7 using this function? I get 7 plus 3/2, which is 5. So I have sent 7 back to 5, which really does help me. I want you to use this one and see what you get. So what do you get when you put an x here? What, in fact, not just x, I want to know what do you get if you put a 7 there? So the good news is you should get, so that's 7.5 plus half, wait, 7/2, which is 3.5 plus 1.5, you should get 5. And the Sunday and Tamir both got that. Okay, this is great news, because isn't the job of an inverse function to send whatever we had at the end back to the beginning? So it sent 7 to 5. Okay, so what have I done in this first 20 minutes? I've basically showed you that if you've got a straight line function, you can get something called an inverse by using a flow diagram and then working backwards on that flow diagram. Give me a thumbs up if the idea of the inverse using a flow diagram makes sense to you. Now, I've showed you this way so you can understand what an inverse is, but to actually find the inverse, there is a quicker way. So let me show you the quick way to find an inverse. Now, it's important that you understand quick way to find inverse. It's important that you understand what an inverse does and that it undoes the original. And so that's why it took so much time to actually show you the process. But in reality, finding the inverse function is actually, there's a quick little method we can use, which I'm going to show you now. So 2x minus 3. Okay, here's what you do. Here is the original function. So how do you find the inverse? Okay, step 1 is you switch x and y around. So if I switch x and y around, I get x is 2y minus 3. Now, why I'm doing that, who knows? But give me a thumbs up if you understand what I was asking you to do there. Okay, here's step 2. Step 2 is make the y the subject of the formula. So at the moment, the y is connected to the 2. And so what I need to do is get that y by itself. So what I'm going to do is I'm going to take that 3 to the other side. Okay? What do you think I'm going to do after that to get the division by 2 going? I mean, oh, I gave it away there. So I'm going to divide both sides by 2. And then what I'm going to get is y is equal to x plus 3 over 2. Now, where have I seen that before? Where have I seen that before? Well, I think it's staring me right in the face over here. That is the inverse of the original function. And what's more, if it's in this format, I could also just rewrite it as a half x plus 3 over 2. And so actually, to find the inverse, you only need to do these 2 steps. It's not wrong to do the long way with the flow diagram, but if you just switch x and y around and then make y the subject, this process works perfectly. Now, we need to practice this, but give me a thumbs up if you understand the basic idea of finding an inverse using this new method. Okay, so now I think what I need to do is I need to give you a new question. So we'll say example 3, and I'm going to give you the function y equals minus 2x plus 7. And I want you to find me the inverse of that straight line. So find me the inverse of that straight line, and you can use this quicker method if you like, or you can use the long method, but you find the inverse for me. Okay, so what was step one? Switch X and Y around. Now I need to get that Y by itself. Let's see if I agree with Sunday. So X minus 7 is minus 2Y. Oh, do you know what I could, if I wanted to, what I could do is I could just move the whole 2Y to this side and then get minus X plus 7. And then I could do that. So I could have 7 minus X over 2, or I could have minus X plus 7 over 2. It's the same thing. And if I rewrite this in standard form, I get minus a half X plus 7 over 2. Give me a thumbs up if you got something like this. Okay, now the true test of whether this works is if I send something through the original function, let's call this f, then if I send it through the inverse, does it take me back to where I started? So I want you to find me the f of 5 for this function up here. What is the f of 5 for this function minus 2x plus 7? So we get minus 2 times 5 plus 7, which is minus 3. Okay, now what we're going to do is we are going to take the inverse function and we are going to feed it the minus 3. Now what I want to know is what do you get when you put minus 3 into the inverse function? And you can use either this one or this one. So if I use this one, I'd get 3 plus, because minus 3 is plus 3. Plus 3 plus 7 is 10. 10 over 2 is 5. Or if I do this one, I'll get positive 3 over 2, and which is 1.5. And then that's 3.5. So then I get 5. And this is glorious news because the original function sends 5 to minus 3. And then the inverse function sends minus 3 back to 5. And so this first half an hour was all about explaining what is an inverse function. It's a function that undoes the original one, our inverse. And the other thing is there's a quick way that we can find the inverse by switching the x and y around and making the y the subject of the formula. Okay, it is time for our halftime break. I think you guys have done superbly. but you know how it is. You've got to take care of the brain. So let's all stand up and just take a moment. And let's just take some nice deep breaths. Breathe in. Breathe out. Breathe in. Breathe in. Last breath. Okay. Then what I want us to do is just to loosen up. So just roll your shoulders a little bit. Oh, I can feel my shoulders are tight. But I ran a race on the weekend, so I think that was part of it. And then roll them forward. And then put your arms to the side and make small circles. And then roll backwards. And then let's shake it up. Let's loosen it up nicely. So loosen up your arms. Get nice and loose. And then shake up your legs. All right, and then let's just put our arms to the side and just twist around a bit. Oh, can you hear all those clicks? My back is clicking. Okay, then shake it up one more time. Okay, then just to get the heart rate pumping, to get us a nice second half of the session, we're going to do jumping jacks in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Woo! And I feel like a changed person. It's been so long since I've done maths, just because of the exercise my body went through now. Okay. Give me a heart pumping emoji or a thumbs up muscle emoji or whatever it is if you're ready to roll with part 2. Okay, now let's say I want to think about the inverse of other types of functions. So let's focus on a hyperbola. So let's say so let's call this the function f, and it is a hyperbola. If I want to find the inverse of this thing, it's a little bit harder to see exactly what's going on like we could with the flow diagram. You know, like if you can see here, okay, this is happening and that's happening, but it's a bit more complicated. So what I'm going to do is I'm going to say, look, I'm going to trust the same short method I used before to find the inverse for this hyperbola. So I'm going to switch x and y around. Give me a thumbs up if that makes sense as step 1 in finding the inverse. Okay. Now, in step 2, what do you think I'm going to do? What do you think I'm going to do in step 2? I think you all know. I am going to try and make this y the subject of the formula. Yes, Tamina, you're perfectly correct. So I don't want to steal from you the joy of achievement. So I want you to try and get that y all by itself using the algebra that you know. And then I will come along and assist you after you've done that. What should we do first here? I feel like that would be a good first step. What should I do next? I think we can do this. We can go y plus 3 times x plus 4 is 2. And then we can have y plus 3 is 2 divided by x plus 4. Now, what's happening there is I'm actually moving this from this side to that side. But essentially, it's times on this side must be divided on that side. Give me a thumbs up if you're okay with that so far. Now, the last step, and I think you will know this, is I need to move the 3 across. And so what we have here is we have the inverse function. We have the inverse function of that hyperbola, which is 2 over x plus 4 minus 3. Now, just to make sure that we've done this correctly, what I'm going to do is I'm going to say to you, we're going to do a little test. What is the f of 3 for this function? What is the f of 3 for this function? You might need a calculator. So we've got 2 divided by 3 plus 3. So 2 divided by 6 minus 4. What are you getting? Okay, so we're getting minus 11 over 3. Okay, let's test out if our inverse does the job. What is the f of minus 1 of, of minus 11 over 3? So I'm going to send it back. What do you get when you put minus 11 over 3 into this relationship here? Well, let's put it in our calculators. We're going to go 2 divided by open brackets, and then it's minus 11 over 3 plus 4, close bracket, and then take away 3, and I get 3. Okay, so the inverse of the hyperbola also seems to be working nicely with this method, which is good news for all of us. Okay, well, why don't we practice this a bit more? So I'm going to give you another function. We'll call it the g of x. And this function is going to be minus 2 over x minus 3 plus 7. And I want you to find me the equation of the inverse of this. So go ahead, use what skills you have learned today to find me the inverse of g of x. So a useful first step is just to rewrite this back into the notation that you're most used to. So I'll give you that hint. Can you get me that y by itself? Okay, let's see what we can do here. So we're going to go x minus 7 is minus 2 over y minus 3. Then I'm just moving the working out up here. So y minus 3 times x minus 7 equals minus 2. Then I'm going to get y minus 3 is minus 2 over x minus 7. And then I'm going to get y is equal to minus 2 over x minus 7 plus 3. And so my inverse function, so I'll put it back into the inverse function notation, should be that. Give me a thumbs up if that brings you joy and happiness. Okay, fantastic. And let's just check that everything is good. So if I say to you, what is the g of, let's say, what is the g of 8? What is the g of 8 going to be equal to? So the g of 8 minus 2 divided by 8 minus 7. No, wait, sorry, 8 minus 3. 8 minus 3. So that's plus 7. I get 33 over 5. And Tamia does as well. Now, what is the g? What's the inverse of g is 33 over 5. So if you take 33 over 5 and you put it into this function here. Okay, so we can see, luckily, it is 8. All right, so what have we done today? We've looked at the idea of an inverse of a straight line, and we understood it with the flow diagram. And then we realized that actually we could use another method or a shortcut to do this. Then we moved on to hyperbolas, and They seem to be working quite nicely. Let's consider another type of function. So let's talk about this type of function. What type of function is this? Any ideas? What type of function would we call this? Maybe I could also write it like this. So this is an exponential graph or an exponential function. Yep, Asande, you are perfectly correct. Now, if I want to find the inverse of this function, I'm going to do the first step, and I'm going to get this. Would you agree with me? Would you all be okay with that's the inverse function? If this is f, then this is the inverse. Now, the problem is, normally the second step for finding the inverse is to get the y by itself. But now the y is floating up in the sky, and that creates a bit of difficulty. Why does it create a bit of difficulty? Okay, well, here's the problem. I don't really know at this stage of my mathematics, how do I get this by itself? Like if I want to write y equals something, the y is stuck up in the sky. So at the moment, I'm kind of stuck with this. This is as far as I can go with my inverse function thing. Give me a thumbs up if you understand that, like that we're a bit stuck. And the reason we're stuck is we don't know how to make this power the subject of the formula. We don't know how to get that y to be the subject of the formula. And this is where we actually in grade 12 will invent some new mathematics, or invent what's called the logarithm, or we'll define the logarithm for exponentials. Now, I'm not going to go into that today. I'll probably go into it in the next lesson. But let's just start with a simple idea. In your calculate, or if I say to you 2 to the power of 3 is 8, would you be okay with that? Okay, now, in the example that I've given you now, really the maths that I'm trying to do that's a bit tricky is how do I write the 3 all by itself? So how can I take what's here but write the 3 by itself? Give me a thumbs up if that makes sense to you. Like how these two are kind of related. It's the same sort of problem. Okay, now, here's what I want you to do. In your calculator, there is a button that looks like this. Give me a thumbs up if you can see that button. So what I want you to do now is I want you to put an 8 here, and I want you to put a 2 here. And the way we say this is we say log 8 to the base 2. And what do you get in your calculator when you go log 8 to the base 2? Okay, surprise, surprise. When you go log 8 to the base 2, you get 3. And so this is a little bit of new mathematics that you're going to learn in grade 12. And the reason we need logarithms is because of this problem up here, that we can't get the power to stand by itself unless we have this new thing called a logarithm. So that problem and this new notation is something that's going to help us. Let's just explore this a little bit before we wrap up today. Okay, so I want to ask you to put this in your calculator. Type the log of 16 to the base 4. What do you get? You get 2. Okay, I want you to type this in your calculator. What do you get when you go 2 to the power of 4? What do you get when you put 2 to the power of 4? You're not going to get 2 because it's 2 times 2 times 2 times 2. I think you would get 16. Yeah, to me I got 16. Now, give me a thumbs up if you can see that there's a bit of a connection between this and this. So we call this the exponential form of the relationship, and we call this the logarithmic form of the relationship. And they're actually the same relationship, they're just written in different ways. But I just want to finish today with a few more little fun things around logs. And then in the next lesson, I'll come back to how we solve this problem here. If I said to you, could you tell me what the log of 27 to the base 3 is without a calculator? Do you think you could tell me what the missing block is here? What do you think is going to be in this block here? So another way to think about the logarithm is, what do you need to raise the power of 3 to get 27? So 3 to the power of what gives you 27? And in your calculator, you should get 3. Did you guys get 3? Give me a thumbs up if you're there. So we're just getting kind of used to this new notation. Okay, what if I said to you, what is the log of 100 to the base 10? What do you think that value is going to be? So in your calculator, I think you are going to get 2. Now, just to show you, with this notation of logarithms, there's the log way of writing it, and then there's the exponential way. So the exponential way of writing the statement would be to write 3. So you take the base, which is here, and then you take this other thing, which is by itself, and write it as a power, and then you drop the log, and whatever's left behind here is 27. If I went from log form here, the base is 10. So I write down 10. The thing by itself is the power. So that's squared, and that's equal to 100. And so one of the skills you will learn in grade 12 is how to go between exponential form and log form, and how this relates to this problem about inverses over here. But that's enough for one day. I don't want to go too far into grade 12.